Hi everybody, I'm glad to be presenting at NACIS this year and participating in this interesting session. So I'll be talking to you about a large collaborative project that I was fortunate enough to be involved in and contribute a small part to. So this is New Uses for Old Maps, Exploring Transforming Landscapes Online Using OCUL's Collection of Historical Topographic Maps. Okay, so this presentation will include an overview of the project summary, context, origins, motivations, goals, and objectives. Then I'll move on and talk a little bit about the workflow and methods used. And then a live demonstration, well, not really, just a short YouTube video with me talking about it. And then future steps to conclude. Okay, so first of all, who we are. The OCUL Council of University Libraries, OCUL, is a consortium of Ontario's 21 university libraries. The Scholars Portal is OCUL's technical infrastructure. It supports, preserves, and provides access to various information resources and services. So some examples of these services are ebooks, e-journals, Racer, and Scholars GeoPortal is a geospatial data discovery tool / portal that is supported by Scholars Portal. Okay, so what you're looking at here, oh great, it worked. Okay, it's an animated GIF of a selection of some of the maps in this collection that I'll be talking to you about. So right here you're looking at Ottawa region at the scale of the 1 to 63,360, so 1 inch equals 1 mile, with the years ranging from 1906 to 1948. So early topographical mapping in Canada was pretty fragmented, with various agencies producing maps at varying scales. The areas mapped were unrelated, and the legends and the colors that they used weren't standardized. So this started to change in the early 1900s, so 1904, when a standardized system of mapping was introduced, which officially came Canada's National Topographic Service, NTS, by 1926, and then in the decades that followed, they produced over 1,100 maps of Ontario alone with these two scales, the 1 to 63,360 and 1 to 25,000. So specifically the project that I was involved in, the OCUL Historical Topographic Map Digitization Project, set out to inventory, digitize, georeference, and provide broad access to early topographic maps of Ontario. So we were able to get our hands on over 1,000 maps spanning the years of 1906 to 1977 in the two series, the two scales I just mentioned. So some timelines and outcomes for a little context. Back in 2011, topographic maps were identified as a strategic goal by the OCUL Map Group, now of course known as the OCUL Geo Group or Geo Community. During 2012 and 2013, some preliminary steps were taken. So an inventory of Canadian federal government maps was created, and a small digitization group was formed and began preliminary work on how they might go about doing this. The meat of the project happened between the years of 2014 to 2017, when there was some funding that was received, and so projected and deliverable outcomes came of it. So this included inventory and holdings information completed. Maps were digitized and georeferenced to standard specs, and derivative products were created, the JPEGs and the GeoTIFFs. Metadata and services were created. GeoPortal the Scholars GeoPortal was customized for optical display to showcase this particular collection, and a project website was created for online access. So a year ago, I came and presented at NACIS in 2016, and back that year the theme was more big data collections. So I was presenting on the Scholars GeoPortal as a service, how it was formed, what was happening after its first launch, and how it was becoming more popular and attracting the attention of our, all the Ontario libraries, and they wanted to upload larger collections. So last year I mentioned this particular project, this historical topo digitization project, and at that time they were saying, hey, there's this platform, let's use it, how do we do that? Now, a year ago, we would think of every data set as a service. But when you're working with the ArcGIS platform, at a certain point, each service starts to cost you space and money. So we had to start thinking a little bit outside the box, take a look at some of the new technologies that were emerging in the industry for creating web application services online. And so a year later, here we are, and this is what we ended up doing. So why these maps in particular? So topographic maps at these scales are heavily used by researchers in the academic community interested in examining changes over time. And access to older series is uneven across all of the institutions, so it was a great opportunity to gather all the holdings, all the 21 universities, get it in a centralized place and have, one point of access for it. And also with the leverage, the OCUL Scholars GeoPortal platform that it had. It was already an established service. Why don't we use this to showcase the collection? And when we received some funding from OCUL, this allowed us to cover some student staffing costs and costs associated with commercial scanning. Okay, so I'll go ahead and start talking about methods and workflow, but here's another animated GIF, this time with the Toronto region, the 1 to 63 360 scale, and the years ranging from 1909 to 1949. Okay, so very broad strokes here. The major steps involved in this project were to build an inventory. So this is shared Google spreadsheets. Then to scan the maps at universities with high resolution scanners, add metadata back into that inventory, and then do a huge array of QA, QC checks, plan for preservation and sustainability, georeference the maps using GIS software, load the maps and metadata onto Scholars GeoPortal, and then build a project site for more accessibility and information. So those major steps are incorporated into the project workflow that we have today, and I'm just going to touch on just a couple of these points here and try and explain some of the issues that we came up with and encountered. So first is getting the inventory. What do we all have? All the universities that had the paper maps had to get together and have some sort of a standardized database that they all entered into. So this was the Google spreadsheets. So we had standardized field names. Everybody had to fill it in properly. It was extensively QA'd and QC'd for typos and whether things are being filled in properly. So it was a standard. So this is the base, the root of the whole entire collection, this which later became a database and things like that. So then another huge part of the project was taking each individual map, preparing it to be scanned, scan it, and digitize it. So this was a very lengthy process. I'm just going to kind of skim over some of the important bits. So we had 600 PPI scans in TIFF with derivative JPEGs, 24-bit color depth, and calibrated scanners, standardized QA, minimum number of scanners were used because we wanted this to be a standard, everything scanned the same way. There's a lot of color balancing going on here, color normalization, stitch processes. So we needed every sheet to be in straight, cropped properly, and no errors. But invariably, when you do a project like this, you're going to come across some errors. So here's just a quick little view of some of the errors that we came across. So the little inset on the left and in the middle are showing you scanner calibration errors. And then the one on the right, that streak there, that blue streak, is pretty much just dust on the scanner. So these may seem like really small, errors, but when you want to have an integrity and an efficiency with the data set as a whole, you have to catch these things. So these were manually checked, visually checked, and if we saw these types of errors, if they couldn't be fixed right there on the spot, the map was pulled to be rescanned. And then another point of evaluation was the georeferencing part. So what we're dealing with here is we have all these maps we have to georeference. We want to do it in an efficient way, have a reliable data set, but then we have, time and funding constraints of the project as a whole. So an evaluation was made for this, and it was decided that an average of 10 georeferencing control points, taking about 15 minutes a map, which would result in about 250 student hours to get all of these georeferenced. So that was done. And then Bottom end of the process involved image reprojection, downsampling, and compression. So first phase is taking those georeferenced images, and instead of creating image services, we opted for using web tile generation and then uploading it up into the Scholars GeoPortal. And then the other derivative products were the common use images, low res, high res, JPEGs that were provided on the project website for accessibility there as well. So here's some more technical information about the project. Obviously, you can get a sense there's a lot of moving parts going on here. And here's a listing of tools used for the digitization, georeferencing, metadata, and web. So a lot of people involved here playing their part. So, color track feed through scanners, ArcMap for the georeferencing, QGIS for verification, GDAL for the web map tiles and the image caches, programming language going on there for the automation of processes, storage containers, the cloud used for hosting the files, ArcGIS server for GeoPortal index services. Yay, that was my little part. Anyways, I'll show you that in a sec. And the GIS editor for metadata, and everything is like talking to each other. And also the project website uses Hugo static website generator. This whole process is repeatable and reusable and available on Git. So if you're interested in that, I can send that out, those links later on. Now it's time for the YouTube. Let's see if I can do this. Okay. So this is just going to be a really short video just showing you how you can discover and access these maps on the Scholars GeoPortal. So here we go to the GeoPortal, and we get the map viewer and our search panel on the left. We've conveniently got a subject category that just isolates for the collection as a whole under historical scan maps. You just click on that, and we got the 2 index maps. This is what I created. I isolated for our coverage and made 2 map services that are uploaded to the portal and adds as a sort of like a connection between the portal and the database behind. So then this particular video adds the 1 to 63 360 index. We zoom in. We find the area that we're interested in, and we click, it's labeled by the NTS map sheet number, and we click on the map sheet, and then that's when the left-hand panel shows us all the results of all the years and editions of the map. You can just click and add. You can download from here as well on this panel, and then you zoom in and start exploring the data and having a look around and seeing what you'd like. Or just discovering it, just having a look and saying, oh, I didn't know that was there, and I didn't know, the changes over time for that. So also on the map tab, you can take advantage of the transparency tool that we have here to look at changes over time, or also look at the change based on, today's situation. So that's the end of that. Am I back? Yay, okay. So as you can see here, I think that the Scholars GeoPortal is a great platform to showcase this data collection. This is all open to the public. Anybody, you can all go and check it out now if you like, to go on there and just search and discover the information for yourself. And you can also, since these are georeferenced, you can download these and put them with your own research that you're working on. You can use them as your own sort of base map or reference material. You can digitize off of the information from these maps and create your own data layers for your analysis. Another point of contact is the project website, and this is very well designed. I find it's got a very graphic design, nice streamlined look and feel. You can look up that if you want right now. And here, this is sort of a very informative website. You get to know about the project itself, like what I've just been talking about. There's a link there for about the maps themselves, like how they came to be, what kind of surveying was done to get the collection, that type of timeline. Then we have collection highlights, where there's extreme, land transformations over time, and we have some, sliding applications on that page, sliding back and forth, and then how to use the map. So in here you have information on how to access the Scholars Geoportal, how to search and discover, sort of what I just showed you with the YouTube video in text form and screenshot form. And then you can actually access and download the entire collection, not the georeference versions, but just the ungeoreferenced version from this site. I think of this site as kind of people that want to find out about the project, find out about the maps, and also are curious about, what their cottage looked like in the 30s, and they just want to print out a map, frame it, and put it on the wall type of thing. You can do that as well. There is great interest for that. So future steps. We are very interested in identifying and digitizing additional Ontario series and making our current collection more complete. We'd love to explore a national topo map digitization project. So other provinces have already voiced some interest. Can we get can we get New Brunswick loaded up? Can we get, things like that? So that's great. We're always, as this project keeps moving forward and shifting, we need to always be aware of the long-term preservation and sustainable needs for digital products. And we are continuously soliciting feedback. So, we are presenting this project, all over the place right now. So definitely please access the Scholars Geoportal site, the website, have a look around, let us know what you think, send an email, and we really appreciate it. So special thanks to all the collaborators involved in the project, a lot of people going into this, a lot of institutions and a lot of people working really hard to make this happen. And thank you so much for coming and seeing the presentation.